Hi, welcome to section 9.3, altitude on the hypotenuse. The objective of this section is to identify the relationship between the parts of a right triangle when an altitude is drawn to the hypotenuse. This is a 2-day section, so for day 1, our homework is going to be out of the book, page 380, numbers 3 through 5, 7 to 13 odds, and 16 and 17. For day 2, we're going to be doing a worksheet. So the first thing we're going to do is talk about what's going to happen with this new theorem. We have when an altitude is drawn to the hypotenuse of a right triangle, 3 similar triangles are formed. Now the first thing we're going to do is actually find those 3 similar triangles. So the first thing that we're going to end up doing here is we're going to actually put some markings in here. I'm going to put a single marking right here on angle D. I'm going to put another right angle marking right here on C, and a double marking right here on B. And I'm actually going to draw my 3 triangles pulled apart. So here's my left triangle. I have an A, a C, and a D, with my right angle formed here and a single marking here. I don't have anything up here at A. Now I'm going to draw that rightmost triangle. That rightmost triangle has an A, a C, and a B, with a double marking on the B, a right angle marking on the C, and nothing up here with A. Next, I'm going to draw this big triangle, only I'm going to rotate it. So for this big triangle, here's my A, which on the big triangle has a right angle marking on it. I'm going to put my D down here and my B up here. Now, my B has a double marking, and my D has a single marking on it. And let's actually match up these 2 triangles right here as far as similar triangles go. My big triangle, triangle ABD, is similar to triangle. Again, we're matching up this left little one with my big one. Now, the A had a right angle marking, just like C. My B had a double, and I had no double here. But my D, which was my last letter on my big triangle, had a single marking, just like my D did here. So I'm going to leave a little space for my middle letter, but I have my D, which means the middle letter of this smaller triangle should be my A. They're going to be similar because we had 2 matching angles, the single markings and the right angle markings. So they're going to be similar by angle-angle similarity. Now, I'm going to match up this big triangle, again, triangle ABD, and I'm going to try and match it up with this rightmost triangle. Again, my A had a right angle, just like on that right one my C did. Then I had my B, which had a double marking, just like my B did here. The only letter left here is going to be my A. And again, they're going to be similar again by angle-angle. They had 2 congruent angles. Now, I'm going to use my transitive property to link all 3 of these together. I know by the transitive property they could cancel out, or we could link all 3 of these together. So triangle ABD is similar to triangle CAD, which would also be similar to triangle CBA, which means all of them should have matching angles because of corresponding, which means actually we would have a double here formed at the A, and a single here formed at the A on the rightmost triangle. We're going to be using these similar triangles to match up their sides and develop proportions for how sides are going to relate. So the next thing that we're going to do is we're going to match up all the sides of the similar triangles. Again, using the same triangles, triangle ABD is similar to triangle CAD, which is similar to triangle CBA. And once again, what we're going to do here is I'm going to put in all my angle markings that we need. So I'm going to put in my right angle here. I'm going to put my single marking here, my double marking here, and we knew because of corresponding angles that left me with a single marking here at angle CAB and a double marking here at CAD. So now, next thing you want to do is match up those sides. So we have side AB would match up with side CA. We have side BD would match up with side AD, and we have side AD would match up with side CD. So I did my first two with my first two, my last two with my last two, my first and last with my first and last, and all of those would be equal. That's using my first and second pair of similar triangles. Next, let's link up my middle and my last one. CA over CB would be equal to AD over BA, which would be equal to CD over CA. Now, linking my first and my last triangles, I would have AB over CB equals BD over BA, which equals AD over CA. All of these would link together as well. Now, I know what you're thinking. This is a lot to remember, and it absolutely is. But these are all going to stem from our similar triangles. Again, how they were similar was by angle, by linking them up, and using the transitive property. All of these proportions are existing because those corresponding sides of similar triangles are going to be proportional. So this next slide is going to be a lot of writing, and this is actually what our theorem says. You might want to press pause and copy this down before I actually start talking. So here's what our theorem says. If an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the given right triangle and to each other. That was the first thing that we proved. We proved that all those triangles were similar by angle, and linked together by the transitive property. The second thing this theorem says is that the altitude to the hypotenuse is the mean proportional between the segments of the hypotenuse. And we also have either leg of the given right triangle is the mean proportional between the hypotenuse of the given right triangle and the segments of the hypotenuse to that adjacent leg. Again, if you didn't write those down, let's make sure we write those on before moving on. Now I know it looks like we went back to that last slide, and we kind of did, but I want to show you how those pieces are actually linking up. So, that part A is that all those triangles are going to be similar. Now for part B, let's reread that. Part B says the altitude to the hypotenuse is the mean proportional between the segments of the hypotenuse. So here's what that one linked together. What we have here is our altitude, that CA piece. What it was the mean proportional, so it was set up on a diagonal, the same diagonal, between the pieces of the hypotenuse. On that big triangle, this was my original hypotenuse, the piece across from the right angle. It was split up into two segments, the DC segment and the CB segment. So linking up these two pieces is actually our part B. Now, our part C. Either leg of the given right triangle is the mean proportional between the hypotenuse of the given right triangle and the segment of the hypotenuse adjacent to that leg. So here we go. Right here is one of the legs. Again, if DB is my hypotenuse, then AD is a leg, and AB is a leg. So here we go. One of those gets linked up right here, and I'm going to change my color to blue. We have the mean proportional. We have the AD and the AD, so they're set up on diagonals. And they're going to be the mean proportional between that segment that's attached to my leg, so you're talking about that CD segment, and the whole hypotenuse itself, that BD. Here's one of the ones from C, and the other one is going to link up here. My other leg is this AB. The mean proportional means that it's going to be on a diagonal. So AB and AB are on a diagonal from each other. That hypotenuse segment is the CB segment, and it's proportional with the whole hypotenuse, this BD. These two is actually what that C from that theorem looks like. So again, A was the similar triangles, B was the mean proportional of the altitude pieces, and C was the mean proportional of either legs. Now I'm all but positive I know what you're thinking. In my mind, this section is one of the most difficult ones to try and comprehend, and I think that's what you're thinking now. Don't stop it yet. hear me all the way through, and then we'll try and make some more sense of it tomorrow. Now, I'm going to try and clarify a little bit. We're trying to figure out what all that means. So we're going to add letters for the side links, and we're going to derive some formulas. Now, this stems from Theorem B, and these are going to stem from the C's. Now, the altitude I labeled A. The hypotenuse I labeled H. The legs I labeled L. And those segment pieces of my hypotenuse I labeled S. So here we go. That second part of our theorem, the B portion, said that we had a mean proportional between the altitudes, so we're going to put A's on diagonals from each other, and both of the hypotenuse segments, so our two segments, S and S. We'll call this S1, and we'll call this S2 for segment 2. And that's actually what that B theorem said. Now those C's. I'm going to call this L1, which matches with S1, L2 because it matches with S2. They're both legs. These are both segments. So our first one says again we have a mean proportional between the legs of the original right triangle. So we'll set those up, L1 with L1. And it's matching with its segment adjacent to our leg, so S1, and the overall hypotenuse H. Now, that uses leg 1. We have the same thing, only it uses leg 2. Again, we have the mean proportional of the legs, which is going to match with its adjacent segment piece and the big hypotenuse. These are what we're going to need to remember in order to make these theorems stick for us. Alright, so let's start with some examples. Let's copy down these triangles, and they're right triangles with an altitude. Let's copy those down and we're going to get started. We're going to do that first one together. Now, I'm going to label my pieces. This is an altitude. We'll call this leg 1 and leg 2, segment 1 and segment 2, but we're missing one piece, that big hypotenuse. Its total distance across is 12, and we'll call that H, because it's the big hypotenuse. So let's start off finding the altitude. That was the B segment. We have the mean proportional with those altitudes, so we'll do X and X, matches with the two segments of the hypotenuse, the 3 and the 9. And let's cross multiply. We want to leave our answer exact, which means a simplified square root. When I cross multiply, I end up with x squared equals 27. Get rid of the square by square rooting, and we want to reduce. Square root of 27. The biggest perfect square that divides into it is a 9. It's 9 times 3. The square root of 9 is 3. The square root of 3, it's not perfect, so we leave it. X is 3 root 3. Now let's solve for y. Y is a leg. So let's do another mean proportional. A mean proportional that links those legs, y and y, and it links it with its adjacent segment 3 and the overall hypotenuse, which is 12. So here we go, cross multiply. And we get y squared equals 36, and let's square root. Y is going to equal 6. Next, let's solve for z. It's again another leg. So we're going to link it up. Z and Z are on diagonals from each other, and it's going to link up its adjacent segment, the 9, with the overall hypotenuse, which is 12. That gives me Z squared equals 108, square root it and simplify. The square root of 108, think about its biggest perfect square that divides in evenly. It's going to be 36 times 3. The square root of 36 is 6. The square root of 3 has to stay a 3. So Z is going to equal 6 square root 3. You try that second one. Press pause and let's see if we can apply it. Alright, here we go. I'm going to solve for x first, and x is our leg. So here we go. We need to know what our overall hypotenuse is. My overall hypotenuse here is going to be 13. So here we go. Let's set it up. We have our legs are across from each other. It matches with its adjacent segment, which is 4, and the overall hypotenuse 13. And let's cross multiply. X squared equals 52, and let's square root it. The biggest perfect square that goes into 52 is 4. It's 4 times 13. The square root of 4 is going to be 2. Square root 13 for our x. Y is an altitude. The way we're going to solve for that altitude is set up those altitudes on a diagonal from each other, y and y, and it's going to match up with those two segments that form the hypotenuse, the 4 and the 9. Cross multiply, and y squared equals 36, square root it, and y equals 6. Last but not least, let's solve for z. Z is another leg. Set up those legs on a diagonal from each other, and it's going to match up with its adjacent segment 9, the overall hypotenuse 13, and let's cross multiply. Z squared equals 117, and let's square root it. The biggest perfect square that divides into 117 is 9. It's 9 times 13. The square root of 9 is going to be 3 root 13. So we have our final answers. X is 2 root 13, y is 6, and z is 3 root 13. Alright, so here we go. One more for you to try. Again, let's copy it down. I have to put my right angles in still. So we have a right triangle with an altitude to the hypotenuse. We want to solve for x, y, and z. Now the one thing that we have to keep in mind is we don't have to go in order of x, y, and z. We can go in any order we would like. So let's see what you can do. So the first thing I would actually solve for is actually my z. And here's my rationale behind it. If I tried to solve for x being my leg, it would use my segment that's adjacent to it and my full hypotenuse, which has a z. If I try to solve for my altitude first, my y, I would need to use both segments, 21 and a z. So again, two variables. If I try and solve for z, I have another option. It's a segment adjacent to my leg of 10. So let's try that out. Here we go. 10 is my leg. This is my segment that joins it, and the overall hypotenuse is 21 plus z. So here we go, let's set it up. We're going to set up the mean proportional between those legs, 10 and 10. That's going to be equal to z and z plus 21. So here we go, let's try it out. Cross multiply. Now I'm not saying it's going to be pretty or easy, but let's see what happens. We end up with 100 equals z squared plus 21z. Now, we have a quadratic. We have a squared piece and a plain variable. In order to solve that quadratic, it has to be set equal to 0. So we're going to subtract 100 to both sides, which leaves me with 0 equals z squared plus 21z minus 100. And we need to solve this by factoring. So I'm going to make two parentheses, z's in the front of both. And what two numbers that multiply to give me negative 100 add to give me 21. Hopefully you said positive 25 and negative 4. To solve this, we set each parenthesis equal to 0. Z plus 25 equals 0, and z minus 4 equals 0. And let's solve it. Subtract 25 to both sides, and z equals negative 25. Add 4 to both sides, and z equals 4. Now we can't have a negative length side, so we know our z is going to have to equal 4. And in case you didn't hear my daughter in the background, we're starting to get ready for bed, but she'd like to say hi.
Hi.
Are you getting ready for bed?
Yeah.
Say bye, everybody.
Bye, everybody.
Say sweet dreams.
Sweet dreams.
Okay, so my Kira's going to kind of help me finish here.
Okay.
But here we go. We have my z is going to be equal to 4.
Okay.
So the next thing that we're going to want to do is, since we know z is 4, let's find our altitude.
Oh.
So here's what we're going to do. Say mean proportional.
Mean proportional.
We're going to set up a mean proportional between my altitude, which is our y's, and those segment pieces, the 21 and the 4. Now what should we do, Kira?
Yeah.
Say cross multiply.
Cross multiply.
Cross multiply. And we get y squared equals 84. Now let's square root that. What's the biggest perfect square that divides into 84, Kira?
4.
Right, it's 4 times 21. See what a smart 4-year-old I have?
Yeah.
That gives me y equals 2 root 21.
Yeah.
So my next piece I need to solve for then. Is I need to solve for my x.
Yeah.
So here we go. What do we set up?
Mean proportional.
The mean proportional. So we have x's on a diagonal, and then we have our segment that's adjacent, our 21, and that's going to match up with our overall hypotenuse, which is 21 plus 4, which is 25.
Yeah.
And let's cross multiply that. When I cross multiply, I end up with x equals 525.
Excuse me, Mommy.
And now let's square root this. What's the biggest perfect square that goes into 525, Kira?
25.
Good. It's 25 times 21. Let's square root that, and
Mommy.
x is going to equal to 5 square root 21. Say
Mommy.
bye, everyone.
Bye, everyone.
Okay, so here we go. Now that my sweet baby girls are in their bed, snug as a bug in a rug, here we have our homework answers. So again, our homework was 3 through 5, 7 to 13 odds, and 16 to 17. Now we are going to be spending 2 days on this lesson. So if you're freaking out a little bit, stop. We don't got to freak out quite yet. Maybe we'll freak out in a couple days, but let's not do it quite yet. If you got major questions, we're going to go through a nice exploring tomorrow. Make sure we hit all these concepts home, and then we're going to spend a second day on it as well. So here's our answers. If you want to get started tonight, great. If you're feeling a little bit overwhelmed, well, we got tomorrow. And as always, have a good one.